right, sorry about having it be in two videos. So the last thing we have to do for this problem, because we figured out our inverse function, is to figure out the domain of the inverse function. And so one thing that, one of the properties that you have to remember is that the domain of the original function and the range of the original function get flipped for the domain and the range of the inverse function, all right? So you don't really want to go based off of your inverse function. You want to go based off of the original function. And in order to figure out the domain of the inverse, we need to have found the range of the original. So our original function is this square root. And if you remember, square root graphs, they don't exist everywhere because you can't take the square root of a negative number, right? So there's kind of some restrictions here. So the x value here would, at 9 is when the square root would be equal to 0, right? If it's 10, then we couldn't actually calculate this value. If it's less than 9, so like 8, then we could calculate it and get a number there. And so what we're doing is we're picking out that starting point of our square root function. So if you remember, square root functions have a starting point and they just go off in one direction. And so that starting point happens when x is equal to 9, because that is what makes the square root equal to 0, and that's the difference between a positive or a negative in your square root. And so what the question is really saying is saying, okay, well, for the domain of the inverse, we need the range, and the range is not about the x values, it's about the y values. So when x is 9, what is the y value? And the y value in that case is going to be 8. So you'll plug in 9. 9 minus 9 is 0. Square root of 0 is 0. Plus 8 would be 8. And so from there, you are going to have numbers that are bigger than 8. So if you put x value in here, take the square root, add it to 8, it will always be bigger than 8. So that means that the range would have been 8 and bigger, so from 8 to infinity. And so the domain of your inverse function is 8 to infinity, and 8 gets a bracket. And so as you're working with these inverse functions, if you have to find domain and range, it can be tricky. You shouldn't go based off of the inverse itself. You should go based off of the original function and either use its domain and range to influence one or the other. There's not a ton of homework questions that ask for domain and range. I think there's 2. I think there's this one. You'll see a question just like this, and if I remember correctly, there's only one other one that deals with domain and range as well. So if you get stuck on those, that would be a great question that you can ask in class, and I can help you try to figure out what is going on there for your domain and ranges, all right? The main point of this unit, though, is can you find the inverse, and do you know kind of the general properties of functions and their inverses? All right, so here's the next one. We have f of x 1 over x plus 2, and we are trying to find the inverse function. So we replace the f of x with the y, and we switch x and y. So I'm going to go ahead and do that in one step. Hopefully you're okay with that. And then from there, you have to solve for y. And so solving for y in this problem might be a little tricky. First of all, the y is in the denominator, and so you have to get it out of the denominator. So in order to do that, you need to multiply, because the denominator means it was being divided, so you need to multiply by y plus 2. And what you do to that side, you have to do this side. So multiply this side by y plus 2. And so over here, you'll have x times y plus 2. Remember, the order in which you read it doesn't really matter. And then on this side, that would just be equal to 1. From here, you're trying to get this y by itself, so you have to get rid of the x and you have to get rid of the 2. It's easiest to get rid of the x first because it's on the outside of the parentheses being multiplied, and so you would get rid of it by dividing. So this 1 would be divided by x. And then last but not least, you can subtract 2 from both sides, so you have 1 over x minus 2. So your inverse function is 1 divided by x minus 2. And the minus 2 is not in the denominator. It was just a regular minus 2. And then you can always, change the y to the inverse notation if you want. There you go. All right, we have one more where we're going to find the inverse. And then from there, looks like we have one where we're going to do some graphing. All right, so first step, change the f of x to y and then flip your x and y's. So I'm going to do that all at once. I'm going to say x equals negative y minus 3 over negative 4y minus 2. So both of those x's will become y's. And then the algebra here is to solve for y. And this is going to be tricky because right now we have two y's. And so we're going to do some algebra to get those y's on the same side of the sign and equal sign. And then we'll go ahead and show you kind of the trick there to solve for y. So this is probably going to be the hardest one in terms of the algebra that you've seen. So just like on the last problem, you want to get rid of this fraction, right? So to get rid of the fraction, you should multiply. And what you multiply on one side, you multiply on the other side. Minus 2 equals negative y minus 3. So the nice thing about doing that multiplication first is you get rid of all of your fractions. On the last problem, we just moved the x over here and divided by x and then solved for this y. But the problem with this one is you already have a y over here. And so you can't just move the x over and then take care of the negative 4 and then negative 2 because you're not solving for y. You're solving for a y, but not y because your answer has a y in it. So that's not going to work for us. So we're going to actually distribute this and get negative 4xy minus 2x. And now I just have a bunch of terms being added or subtracted. And so what we're going to do is we're going to take everything with a y and put it on one side and everything without a y and put it on the other side. So I'm going to move all of the y terms over to the left. So I'll add y on this side, and then I'm going to add the 2x over here. So that'll be 2x minus 3. You could say negative 3 plus 2x, right? You could have put that on this side as well. All right, and then here's the trick. Now that you have both y's on the same side of it, the equal sign, we're going to take both of these y's and turn it into just one y so we can solve. And what we're doing is we're doing a greatest common factor on this side of the equal sign. And we're going to take out a y. We're factoring out a y. So you have negative 4x and a plus 1. So you're factoring out that y from both terms, and then here is what was left over. So that's kind of the step, that factoring step is how you go from having two y's to having just one y. So now it's pretty easy to finish solving for y. You're just going to divide by this set of parentheses here. So your y will be equal to 2x minus 3 over negative 4x plus 1. So that is your inverse function since you have officially solved for y. So a lot of algebra associated with that, and the hard thing is you have to know kind of the tricks of the algebra. All right, so you kind of have, it's not just in general like, oh, you just add, subtract, right, multiply, divide. There is kind of that like, hey, you have to do a factoring step here to get that y by itself. All right, so then that would be your inverse function. So you would just plug that in as your solution. Negative 4x plus 1. All right, and then the very last question here, we have a graph, and we want to graph the inverse function. And so this is using the idea that if you remember, your x and your y are going to switch locations. So based off of your original function, your x and your y's, they'll flip and create your inverse. So what I highly suggest you do is you make a table for your original function, and then we'll take that table and we'll make a new table for the inverse by flipping our x and our y values. So we need x, y values for our original function so that we can flip them for our inverse and plot those. And if we're looking at this, you definitely need to have your endpoints. And then since these are line segments, you need the points where the line segments change. So this line segment changes to this line segment at that point. So we're going to want that point. And then there's another change between the line segments here. So that's how we'll get a very accurate graph, is we're going to pick the endpoints and then we're going to pick the change points where the graph is changing. So we have -6, 3, -4, 0, -1, -1, and 1, -3. Those are my original 4 points. And then to find the inverse, all you have to do is flip them. So your y's become your x's, and your x's become the y values. So just flip-flop. And then if you plot these as xy coordinate points, you will have your graph of the inverse. So 3, -6 is down here. 0, -4. -1, -1. So that happens to go through that same point that was on the original function. And -3, 1. So this point up here. So you'll just connect in straight lines, because your graph was straight lines. You'll just connect those dots. And so here's your original function, here's your inverse function, and if you remember, it just has to be a reflection over the line y equals x. And so this piece was a reflection of this piece, and then this here, it was reflected down there. So you can see the reflection. And this point was on both of them because that point is on the line y equals x. All right, so that is it for inverse functions. Go ahead, you can be working on the homework. Let me know what questions you have as you're working. I am here to help, all right?